Good afternoon, participants. First of all, I want to take the opportunity to thank the organizing committee for the invitation to be session chairs, and then congratulate of all of them for the success of this event. It's very pleasant for me to present to Victor Grimblatt for the next conference. I know Victor and all the work he does in this topic. Victor is an electronic engineer, has an engineer diploma in microelectronics from Institut National Polytechnique de Grenoble, and an electronic engineering diploma from Universidad Técnica Federico Santa Maria from Chile. He's doing his PhD on IoT for smart agriculture in IMS Lab, University of Bordeaux. He is current R&D Group Director and General Manager of Synopsys Chile. He has expertise and knowledge in business and technology and understands very well the trends of the electronic industry. Therefore, he is often concerned for new technology business development. He has published several papers in IoT, EDA, and embedded system development. And since 2007, he has invited to several Latin American conferences, for instance, Argentina, Brazil, Chile, Mexico, Peru, and Uruguay, to talk about circuit designs, EDA, IoT, and embedded systems. Since 2012, he is chair of the IEEE Chilean chapter of the CAS. He is also the president of the Chilean Electronic and Electrical Industry Association. He has been part of several conferences, TCP, for instance, ISCAS, ISECT, LASCAS, and is chairing the EDA and Circuit Design Subcommittee for ISEX. And he is also program co-chair of FoodCast. Since 2018, he is chair of LASCA's steering committee. Please, Victor, you have the microphone.
Okay, so thank you very much. Good afternoon to everyone. I hope you hear me well. And thanks for the organization of the conference to invite me to give this talk. I was expecting to go there, but unfortunately I am here in Santiago. Normally I go to Brazil several times a year, but this year I think I will have to stay here. This is much better and much safe. So my talk today will be the application of technology in the agribusiness, and Carlos presented me very well with all the things I have been doing for several years. So thanks, Carlos, for that. So let's go to see the topics of the conference. We are going to talk about the problem. So what this is, it is so important, the agribusiness in Latin America. I'm going to provide a couple of relevant agriculture data, and after we are going into the IoT, main concept and architecture, and the IoT in the agriculture, and IoT is everywhere and in all fields of application, and conclusion of this work. So what is the problem? Why this is so important? Why we have to apply technology to the agriculture? Hold on a second. Okay, no, this is too much. Okay. So the first consideration we have to take in account is that the population of the world is growing exponentially, and at the same time we are having a problem with the fact that we have to feed all those people. We are talking about 7 billions of people by the end of this century. And another problem is at the same time we are growing the population, the arable land, and we are going to talk a little more about the arable land in the next couple of slides, is going down. Arable land is the land we can use for the agriculture. So we have more people, but we have less space, less arable land to use for the agriculture. But we need, so as we have more people, we need more food. So there is already here, we are seeing a problem. And if we look at the numbers in the 60s, we were having around 0.5 hectares per person, and today we are almost at 0.2 hectare per person. Okay, so on the other hand, okay, there is a little delay. Okay, so arable land refer to the land under temporary crop. Okay, so this is the definition that is in all the source we are using for getting this number. So this is in fact, the land that is used for the crops and for also for the pasture, the land, and so on. So continue on that. If we look now across the world, we will see that we have the arable land has been decreasing all over the world. However, I would like to mention that the European Union, which is the one that is in the top of the graph, has been decreasing, but they have an important part of their area that is used for the for the arable, for the agriculture. They are around 24-25%. In our region, we are only, this is Latin American Caribbean, LAC, we are only at 8%. And I took also the value for Brazil as the conference. In Brazil, you have just 9% of your land is used for the agriculture. So we go into detail of our region, we will see that we have been decreasing. Some countries are trying to increase a little because they have found that agriculture can be an important business. Peru, for example, is trying to compete with several products. They are trying to export things and so on. But in general, we are going down, and that is a fact that we have to consider. So we have less land that we had in the past, but we have more people to feed. Another important thing is that the farming system in Latin America and Caribbean, so the green part of the of Brazil is mostly forestry. So this is the part that is used for forestry. It's not giving direct food. I know that there is a lot of problem in the Amazon now that people are changing because of what is happening. They're changing and they are having more farm exploitation in the Amazon, but this is what it was taken from this source. So we have that part. So the farming system in LAC, there is some part of irrigation and some part of desert and some part of forestry. Okay. Another important fact to consider is the climate change. We all know that the temperature is increasing. We have a climate change that is provide the temperature rise and associated climate phenomena that are causing impacts. In the short term, we are going to see greater climate variability, extreme events. Long term, we are going to shift in mean climate conditions. We are going to see something very interesting on that in the next couple of slides. And agriculture is one of the most climate sensitive sectors. So for the agriculture sector, the climate is very important. And let's analyze that a little more. And we see in that the red areas are decreasing the agricultural production for 2050 because of the climate change, and the green areas are increasing. And we see that the increase is mostly in the north hemisphere of the world, because today those parts are too cold. With the climate change and the increase of the temperature, the climate will change in these areas, Russia, Canada, the north of Europe, and they will become good places to have agriculture. However, in the south hemisphere, as you can see there, we are going in the opposite direction. So as we are increasing the temperature, we have more dry problems, we are more irrigation problems, we are less water, less rain. So we are decreasing our capability to produce agricultural production. And Brazil is one of the places that this is very well shown in that figure. The rest of Latin America is decreasing a little the production for 2050. Now, if we look in another way, in this part, we see almost the same phenomena, but this is for cereal crop productivity and the livestock productivity. And we see also that the south hemisphere is being impacted. At least here in Chile, I know that a lot of people from the central area of Chile are moving all their animals to the south part of Chile where there is more water, because in this area of the country, animals cannot eat, they don't have water, so they are moving that to the south. But again, the North Hemisphere is being favorized by this change, because they are going to get better temperature for the agricultors. So the climate change impact in some regions, we have in Latin America productivity decline in semi-arid areas, biodiversity loss in Amazonas. In Africa, the productivity decline, food insecurity, biodiversity loss in East and South Africa, malaria in highland of East Africa. In Asia, lower fresh water availability, lower crop yields in Central and South Asia by 2050, flooding of megadeltas. This is also due to climate change in the Mekong and the Ganges and the glacier melting. And a small island, degradation on coastal ecosystem and decreased water availability damaged infrastructure. So the climate change is a very important factor for the agriculture or for the world in general. Another problem is the emission we are sending, the CO2 and so on. And we see that the agriculture, forestry, and land use change are cause 1/3 of the emissions that are bad for the earth. So, in one hand, we are doing the emission with the agriculture, but the agriculture needs a change in the climate to go back in the climate so they can get the water and they can get everything they were having in the past. So there is a contradiction between what we have today and what we need. And that is very well seen in the next slide, which is the ecological footprint. The meaning of the ecological footprint is that in the x-axis of the graph, you see the resources of the earth. So 1, 2, 3, 4. See, this is the ecological footprint. So we are using 1 resources per year, 1 time the resource 1 year, 2 times, etc. Today, we are, based on the production we are doing from for the food, we are using 2 times the resources of the earth. And if we continue the same way, in a few years, we will be using 4 times the resources of the earth, which is impossible. We cannot do it. We are going to destroy the earth. Okay? So we need to change that. And we have to come back to the green point, where we use only the resources that are available to produce the food we need. Sometimes there is a delay on charging the slide. This is the reason I'm stopping for a few seconds. Also, from the United Nations Food and Agriculture Organization, we know that for 2050, we will need to increase 70% the current agricultural production, meaning that we will need to increase almost double current production. So to feed all the people that will be on the earth in 2050, we need to at least double the current production. Fresh water is another problem. Agriculture is the heaviest consumer of our planet available fresh water. 70% of blue water withdrawal from water course and groundwater are destined to agricultural usage. And the problem is that we are losing almost 50% of that water. Water is very important in South American countries. We see that 72% of the water, the fresh water available in Latin America, go to the agriculture. Okay, so agriculture is the global water demand, and is estimated to increase by 19% by 2050. So the problem will become bigger and bigger. This is also the level of physical water stress, meaning that where we're stressing the water sources because the need of the water, and we see that the United States is quite well. Latin America is we have we have a stress between 10 to 25%. The north of Africa and all the Middle East is becoming very complicated with 70%. And we all know that, for example, Israel has increased his agriculture because they have studied the irrigation. They have created a lot of different things to make that change. So to summarize those problems, we have more population to feed, less arable land, a climate change, less fresh water, and ecological footprint. So how to solve this problem? So my proposal and the proposal I'm working on is Internet of Things. Just to provide some data about agribusiness in Latin America, this is our continent. So first of all, to define the term agribusiness, that will come later. So the agriculture, forestry, and fishing value add as a percent of the GDP, you have there the different part of the world. So in East Asia and Pacific is 4%, 4.7, Latin America 4.6, North America 0.9, etc. This is the value of the GDP of the agriculture, and it's been going down from a while. This is another way to see that on different years, Argentina, Bolivia, etc., etc. And we see the agriculture has been very important for El Salvador. Today is no longer the case. Honduras is still very important, as well as Paraguay. But for the other countries, agriculture has been decreasing dramatically from the GDP, and we are not doing too many on that area. There is also the food production index. First of the exportation, the percent of exportation of foodstuff and vegetable product. This is the value. So they are approaching certain numbers that are quite interesting for some countries, less for others. And we see here who are the countries that go more to the food and who are the countries to go to the vegetable products. Yeah, food production index that is showing how much food we produce. So it has been growing in the countries. Paraguay is a very dramatic growth, Peru as well, República Dominicana, and some other countries have less growth. But this is we see the trend of this food production that is going up as the food is becoming more and more important. And you have to see with this pandemic, food is the thing that people are most consuming. Today we can forget a lot of shops, but supermarkets have to be open, grocery have to be open because we need to eat. We need to feed ourselves. Arable land, we already told, but this is a more detail about Latin America. So you see who are the countries. El Salvador is increasing. Uruguay has been decreasing the arable land, but now it is increasing. Argentina is increasing, so you see that different countries are doing different things. Peru has been increasing and going down. Brazil is increasing the arable land across the country. So this is a change that we already see that one. So some relevant agriculture data we are going to see now is that first of all the term. This system was coined in 1957 by Goldor and Davis. It's the business of agricultural production and include a lot of domains like the agri-chemicals, breeding, crop production, and so on, etc., etc. Some interesting facts: approximately 1/3 of the food produced for human consumption is lost or wasted globally. It's starting to change. For example, I know that the law in Chile forgive restaurants to give the food they are not using to people. In Europe, they are starting to do that now, but I don't know in Brazil or other countries of the region. But in general, what is same for the validity date or the date of the food, we know that we can extend that date, but things are wasted because just of the validity date. The food product represent an important part of the emission produced by the transport sector. The world crop yield increased by 77% between 1961 and 2007, even before the internet and even before the technology we have today. Emissions from primary production have been reduced by 23% in the period 1990 to 2012. again before the internet boom. An improvement achieved through non-internet technology. We see the mechanization of field operation, improvement on new units, environment-friendly cultivation techniques. So we are talking about technology in the agribusiness since the 60s. But today the difference will be the internet, and we will see how we can apply the internet and these kind of things today in the agribusiness. So the main actor in the value chain that is important to know, we have the farms, we have also the logistic companies, the food processing companies, and a very important actor is the consumer. The consumer is a very important actor because at the end, the one that is going to have that food is the consumer. So different type of production at the farm level. We have the arable agriculture, the greenhouse crops, and the cattle raising. Farmers and food processors must deal with many interrelated objects. This is a very special domain because we have too many interrelated objects. For example, at the farm, we need the seeds, the animal feed, the fertilizer, and the pesticide. The resources we have at the farm is the land, the stable, the tractor, and other equipment. The agricultural products, animal, processed food, and the fresh products, and the logistic, boxes, pallets, container, trucks, and so on. So it's a very complicated ecosystem, it's a very complicated domain. And if we see now the agricultural ecosystem, so we have the farm in the middle, we have the agronomists, we have the vets, the certification inspection company, the authorities, the consumer, the input supplier, and the contract. So it's a very complicated and diverse ecosystem, and no one of them are using equivalent technological equipment or equivalent technological software. Agronomists are using one kind of things, but the input suppliers are using other kind of software. The consumers are, right now we are using a lot of software because we are ordering our food over the internet. We do this, we buy it on the supermarket through the internet, but the consumer are using different things. And for example, one of the nice dreams of IoT in the food is, let's say that I have a lot of cameras into my refrigerators, and those cameras are telling me what is important and what I have to buy from the supermarket, and someone, don't know who, but a robot will send the information to the supermarket, and the supermarket will prepare my food and will send that to my home using any kind of transportation system. I have to pay. So we are interacting different systems. We will have the transaction system for the payment. We have the system to send the order to the supermarket. We have the system that is taking from the order, will go to the warehouse to bring that product. We have the system that will transport that to my home. So it's a very complex and very diverse ecosystem. And this has been one of the problems why technology is not so broad across the agricultural, across the agribusiness. So let's go now to IoT, some main concept and some architectural stuff. So what is IoT? This is very easy. Okay, I'm asking, I got a request to close my camera so we can have a bigger slide. I'll do it immediately. Okay, I hope this is much better. So what is IoT? So there is a couple of definitions. We are going to use one or two, but in general, the Internet of Things is the network of physical objects or things embedded with electronic software, sensor, and network connectivity, which enable this object to collect and exchange data. And also, we can say that IoT is it's a little slow, sorry for that, allows objects to be sensed and controlled remotely across existing network infrastructure, creating opportunities for more direct. As a summary, IoT is the connection to the connection of the physical world to the digital world. So I'm connecting something that is physical, something that is in the earth, an object, to the internet, so I can use that data to better and to improve what I can do, the production and so on. And things are everything. We have a cow, we have a tree, we have some lettuce, a container, building, a car, whatever you want could be considered a sink, including ourselves. We are also sinks for a lot of application. The perspective of IoT is anytime, any place, any sink. So it's outdoor, indoors, on the move, or out night and daytime, human to human, human to sinks, and sink to sink. But I know that you know all that. Market application, IoT is everywhere, smart home, industrial IoT, connected vehicles, smart cities, whatever, health and fitness. And today, I had for the first time a consultation over the internet with a doctor because I'm having a lot of allergies. So I make an appointment with a doctor and we were chatting using an application that the hospital has put in place. So that was my first time. And after he sent the prescription over the email, that was wonderful. And I pay using my credit card. So the first time I doing this kind of things that will become normal now. Why now? Because why we are talking about IoT now? IoT is a very old concept. It was called also in the past machine to machine and so on. Because sensor and communication device cost has decreased. They can be added to any device you want. So today is very easy and very cheap to add a sensor to a washing machine, a traffic light, a refrigerator, without impacting the final cost. Okay? Because it's very important that consumers will not pay an over cost if they don't see the value. So they need the producers of goods. They need to include the sensor and the actuators without making an impact or without a big impact on the final cost. There's a story I remember when I was working in Motorola a long time ago. So we were working on the digital television and Microsoft was proposing an operating system for television. And the problem at that time is that this operating system was quite big, so we were forced to add a hard disk into the TV set. And the producer of TV said, no, people will not pay, so you have to change that. Finally, they changed the operating system and they create a small operating system that could be added to the TV without adding a hard disk. Wireless communication also available in almost all places. We have to think a little about in rural zones. There are communication options without operating costs that we are going to talk, and power consumption has decreased, allowing device to work longer with the same battery. If we think on the agriculture and putting a sensor in the middle of nowhere, I don't want to go every 2 days or every other day that place to charge the battery. I want the battery to be alive for almost a year, 2 years without me going there. Also what we have, the key players enabling IoT. So we have the semiconductor industry, lower barriers to product creation, cloud industry, lower barriers to create new services, and telecom industry, lower barriers to be connected. So those are the main players and the enablers of the IoT. You can ask me about the software. Yes, the software is very important. We are going to talk about software later, but without the semiconductor industry, there is no software. Without the semiconductor industry, there is no cloud, there is no telecom. So semiconductor industry is very, very, very important in that domain. Take a little of water. So the typical architecture of a IoT system is the IoT edge, what we call the edge, which are the devices that are close to the things. We have the aggregation layers, which is the hubs, the gate.
Hello.
Hola.
Communication with Victor dropped. So let's wait a little bit for establishment of the connection. So after the talk of Victor Grimblatt, we're going to have a talk by Elkin Roa, directly from Colombia. Then the third talk of the afternoon will be a talk by Professor Sergio Bampi, and the fourth one, a talk by Giusi Suto, directly from Portland, Oregon. Then we have the closing session with the South Symposium awards, and then to finish our event, live music show. So Victor is going on again. Waiting for his microphone. You can also start putting your questions for Victor in the chat.
You hear me now? I hope.
Now it's okay.
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 Okay. So,
Okay.
so
Okay.
sorry. So sorry for that mistake. My fingers touched the wrong button, and I create the problem. Sorry for that. Okay, so I was talking that this is the normal architecture. You have the sensor and the actuators that are close to the things. You have the device that is processing all that, the gateway and the cloud. And after we go so the big question, how to connect a thing to internet, because we have a lot of electronic, but I have a lettuce and I have a cow. So I don't think a cow will have a microprocessor inside, or a lettuce will have a microprocessor. So we have what we call the node that is connected to the sensor that is put into this thing, this cow, for example. And that node will be transmitting information through radio link to a gateway that will transmit over the network, over the internet, to the end user, or to the database that will be used to make the processing and so on. So what is the node? Because we are talking about a node. So a node is a small electronic device that have a sensor, actuators, interface that are interfacing to the real sensor and the current sensor that are in the land or wherever, in the cow. We have the digital part, we have the radio frequency part that is transmitting the data and receiving some other, the power supply and the security. This is a node that is connected to the sink. And what kind of connection type and how to choose, because we have a lot of connection time, but we try to choose the connection time based on the amount of data we like to transmit, and also on the distance. So if we are using Wi-Fi, so Wi-Fi is very good for a big rate of bits, so 100 megabytes per second, but it's not going too far, just 1 kilometer. In the agriculture, normally we have things that are several kilometers from our center, so we can use the cellular, but this we have to pay for that, or we can use what is called the low power wide area, which is Sigfox and LoRa, and good examples of that. And in my personal case, I'm using LoRa for my application, which is a very convenient network with very low rate, so I can transmit a few bits and I can get very far, a few kilometers of distance. So this is a table with the different connection type comparison. So I'm not going into detail into that, because if not, the conference will be too long. But we have, for example, the Sigfox is very low power consumption, is a medium range, the maturity is quite new, is quite low, availability is very low, is the security, I don't have any data, but the usability is low, data rate is very low. If we took the GSM, GPRS is the opposite, but you have also to pay for that. So 5G, people can ask, yeah, but what about 5G? Okay, 5G is very good. It will provide a lot of benefits, increase the speed, we will decrease the latency, we improve the flexibility, decrease the latency, we improve the performance application. But in the rural area, sometimes there is no even 2G. So we are not going to think in 5G. So there are areas, at least in Chile, and I'm sure in Brazil as well, where you don't have any connection to the internet over any network. So we have to use things like LoRa or Sigfox, things that can be used in the rural areas. Okay, this is very important. Data processing. Normally, when we start the Internet of Things, we thought about the cloud, so which is only convenient when an action is not immediately requested. We can have bandwidth issues. Cannot send all the data to the cloud because no change is a very small change. Some people are used the gateway, but the edge is becoming the common place to do the processing. It's very efficient, needed for fast action. If we take the example of a car, those driveless car, so the car will face an obstacle, and with the cameras will have the analysis of the obstacle, and they need to decide they have to brake or no, if the obstacle is a person or is something different. If we have to send that data to the cloud and wait for the cloud to analyze the data and send that back to the car, maybe we already hit the person. So we need fast action. This is the reason that the edge is becoming more and more common. And according to some statistic, that will become the most common part in the near future. So okay. So edge computing refers to the computation and analysis of data on distributed device positioned at the edge of a network rated on a centralized system, and according to Gartner, that will be the most important thing. So Gartner anticipate that by 2025, 75% of data processing will move to the edge. In 2018 was just 10%. So the edge architecture, just to come back, the battery, the energy harvester, the sensor, the actuator, the software, the processor, the storage, and of course the radio frequency to transmit and to receive data or orders. What are the key design requirements for these kind of devices? The wireless connectivity, the security. We have to be sure that the device is secure, the sensor processing, how much processing and where will be on the chip integration be. So how much integration, how much processing will be done in the edge, and add connectivity, security and processing while extending battery life. All the things that are there will require power. So the more we add as functionality, the more we need power. So the more we need to be efficient with the power. So the incredible opportunity with hardware. So we talk about the low power system, cost, integration, and security. Battery life is expected to extend while adding connectivity. The type of functionality, connectivity, and energy use dictate cost. Wireless power managed memories, and of course the security that we are going to talk a little more about that. But this is important, the energy consumption. So this is different kind of application and how much power they need. And you see, for example, a GSM cannot go into the energy harvesting or what can be produced by energy harvesting. So, for example, we try to avoid the GSM communication, or we try to do as less as possible because that consumes a lot of power, and same for power tools and things like that. So we have to be very careful. So when we decide and we are defining an edge, we have to consider the power budget, including the active sensor power, the frequency of data collection, the wireless radio communication, frequency of communication, and so on. How often the processor will be sleeping, the energy loss from leakage, the power reserve for actuators and motors. So we have to analyze all that before we decide what we can do on the edge and what kind of battery we have to put on the edge. The trends on edge device, connectivity, interoperability is critical. Low power wireless technology, Bluetooth, different 802, the LoRa, the security. We need to protect the IoT device against evolving threat, and current system with limited encryption or software base are not enough for that. So the energy efficiency also we use to the energy usage impact the battery life and the cost. So we need also to work on that. The IP needs to be re-architected to optimize for low power. So we need to think immediately on low power when we define and design an edge. The sensor processing, adopting new and improved sensor and control function to improve the user experience and overall system efficiency. Some examples coming from Synopsys. This is a high-end SoC for things like very sophisticated visual processing, face recognition, and so on. high-end SoC for IoT, but we also have the low-power IoT. This is another example, which is low-end SoC. This is low power, and we have a few components, and of course we have interfaces for the sensors and actuators. And what is important is the way we design that. So this is the basic step of digital design, and just to remember, because we have to do digital design to do the edge, we have the IC description, the simulation, the synthesis, and the physical synthesis. And this is a more detailed digital design flow. So we have the RTL, we go into simulation, we synthesize, we verify, we have the static timing analysis, we see that the timing is okay, and after we go to the physical part to do the floor planning, the place and route, the physical verification, and once we are finished, we can send that to the fab to manufacture our devices. One important thing is a lot of embedded systems that are used today are using 8-bit microcontroller because of the speed. If we have this kind of architecture, which is a bus-based architecture, which is the normal one used on a lot of embedded systems, so we have the CPU, which is an 8-bit, and after we have the bus that is slower, a lot of time from the CPU that go to the memories and to the bridge, to these different IPs that will make the connection to the external world. And Synopsys has proposed a new kind of architecture that we call the busless architecture. We have components that we call the couple components to the like memories, and when we call the IPs are, for example, the I2C connection, the SPI, etc., etc. Okay, so this is the new. So we can use the 32 bits without any problem, any loss of speed. Finally, on that part, I would like to talk a little about security. What are the security risks, disruption, and denial of service, vulnerability management, etc., etc. And of course, we do a lot of. We try to improve the security on the computer-based system, but when we are talking about IoT, we do less things. This is a very common example. This is a remote. This is the kind of device that are used to monitor our kids when they are babies, and that was hacked. And we changed the communication, so the parents were not knowing anymore what was really happening with the baby in the bedroom of the baby. So the security threat are top concern for IoT development because they can happen at any level, at the network level, at the device, and even at the chip level. We have the hardware, the non-invasive, the backport, the side channel, or invasive decapsulation probing. On the device, we have the typical thing, the typical hacking of the credit card, the magnetic band of the credit card, where the hackers put something on the ATM to take all our information, and on the network level, of course, we have all the communication, the sniffing of sensitive data, password, credit card number, etc. So the challenge in IoT implementation that are based on some survey done to the companies, 32% is IoT security, 31% cross-department cooperation, 30% integration of disparate data, and 29% availability of skilled talent. So be prepared if you are a student, 29% availability of skilled talent. We need people that understand IoT and understand everything that is related to that. So ensuring the success of an IoT project, we need the hardware and software to power source and power management, the hardware security, sensor, processor, components compatibility, the hardware option. I'm going to buy the device, I'm going to design the device, the operating system, the software battery requirements, the software security. But there are other things, not only the software and hardware, there is also the connectivity and device management, the system security approach, and the structure and management of data that is as important as the other part to ensure the success of an IoT project. Do not think that because you have a small prototyping board that you have your system. So this is important to do the proof of concept and prototype. The proof of concept is allowed to validate assumption, allowed to validate algorithm and reduce version of the system. And the prototype meets the main system requirement. Various prototypes are made for a field test, allow the usage of the product without mass production, and for low volume, the prototype can become the product. And an interesting thing is that if you take this kind of thing like the Raspberry, the Arduinos, and so on, you can do a very good proof of concept or a very good prototype, but maybe that will not be the mass production. Consider an Arduino on a collar on a cow. It's quite big. So the collar, maybe you have to do an integrated circuit because that will be much better for the cow. So IoT in agriculture. So we have what is the potential, better detection and monitoring of production, better understanding of specific agricultural conditions, climate and environmental conditions, animal welfare, and so on. More sophisticated and remote control of the farm. We need to control the farm remotely. Let's assume what is happening right now with this pandemic. So people cannot get out. So they need to control remotely what is happening. Also, we have the improved monitoring and traceability of food quality through remote control of the location and condition of shipment. Do not forget that the food is perishable. So a lettuce will be good. You can eat that lettuce for maybe a week. But if your lettuce is produced today and you will sell that in a month, your lettuce will not be good. So you have to take aware of that. And we also have the increases consumer awareness of sustainability and health problems through personalized nutrition. People want to understand everything they are eating. They want to know everything. They want to even know the name of the cow, of the steak they are eating. Okay, so people are consumers we become more sophisticated and we want information. So the smart agri-food domains are the smart farming, the smart agri-logistics, the smart food processing, and the smart food awareness. So precision agriculture and smart farming, let's do a little different. Precision agriculture is about the very precise monitoring, control, and treatment, but the smart farming is adding the real time. And it's also adding the management tasks on location and data enhanced by context and situation awareness, triggered by real-time events. So the precision agriculture is to monitor something. But if we had that real-time data, that awareness, that becomes what we call today the smart farming. So the smart farming, we have the sensor, the analysis and planning, and the control that could be based by a robot or just an alarm sent to the farmer. The smart logistic is handling of food impose the dimension of perishability upon all agri-food chain step, and decision need to be based on the fact that quality characteristics change over time and due to environment conditions. So this is something I already told, but is critical for the food producer and for the consumer, that concept. We have the smart food processing and manufacturing. Food processing plants are currently centrally controlled. We want to decentralize that. So IoT will be able to do that. Machine become physical system with embedded intelligence and local data processing. Machinery adapt to the new production requirements. Today I'm producing A, tomorrow I'm producing B, and the machine have to adapt to this production requirement because today consumers are consuming A and tomorrow they will be consuming B. Foodness awareness, the consumer want to believe in food, and this is very important, to believe in food. I want to believe in what is put on the label and the nutritional properties. The consumer wants to know the origin and all the actors involved. So IoT will change the process and business models such as data-driven agriculture, the circular economy, the green agriculture, the food, the autonomous agricultural operation, demand-driven agriculture, urban agriculture that is becoming very important because of this pandemic, agile food factories, brutal food chain, and personalized nutrition. We also have an application to tell me what I have to eat. And I have found a very interesting application because of this pandemic that you tell what you have in your refrigerator and they provide you a lot of recipes to consume that with some other things you could have in your refrigerator. So as a benefit, you have the water conservation, the real-time data and production inside, the lower power operation cost, the increased quality of production, the accurate farm and field evaluation, the improved livestock farming, the reduced environmental footprint, and remove monitoring. So if we look at the problem we presented at the beginning of the presentation, we are solving on those benefits. We see that we are solving those problems. At least we are helping to solve the problems. Technical challenge today, interoperability and standardization. We have a lot of systems, they are not interoperable. Enablement of IT devices, computing capabilities of the edge. We have to do more and more edge computing. Enabling network, cloud and communication in rural areas, information services, data security, and IoT platform. Non-technical challenge, because it's not only technical, it's the business model. We have to justify the investment because there is money invested on that, so we have to justify that using showing result. The solution cost, digital capability of actors. The farmers, they don't understand the digital world. They can maybe use WhatsApp, but if you are asking them to do other things, that will become complicated. Policies and regulation and stakeholder participation. So IoT is everywhere and in all fields of application. So we have here in this picture all the places, but we're interested in agriculture. So in agriculture and environment, we have the smart irrigation and fertilization to improve the productivity, smart lighting on hooks to improve productivity, even that some ecological organization are contesting this part because this is what we put for the chicken to produce more and more eggs, livestock health and asset tracking, preventive maintenance in remote equipment, soil analysis by drones. We're also talking about in situ sensor for soil analysis, asset management from farm to market, robotics on the farm, and monitoring of volcanic lines and fault for disaster prediction. We also have subsector used by the European community. They are working a lot of, they have this organization called Internet of Food and Farms, so they are working in 5 domains. The Internet of Arable Agriculture, so operation during the herbaceous cultivation cycle. Oh, sorry, this is in Spanish, sorry. The Internet of the milk, the dairy industry, the Internet of fruits. I was having this presentation in English and Spanish, so this one just remains Spanish, sorry for that. The Internet of vegetables, fully controlled greenhouse, semi-controlled greenhouse, unregulated environment. The Internet of food, control the growth of the animal. So this is the domain that the European community that is very advanced on that, on the Internet for food is working. The agribusiness threat is important because we can think that security is not so important, but the FBI has already identified agriculture as an industry with cyber risk. Protecting the information technology asset of the agriculture industry is just as important as protecting those of banks, hospital. IoT device and sensors are the most dangerous and need protection. Hacker or cybercrime can access farm data to predict market availability and price. So this is very important. Or malicious actor could sell farming information to competitors. Or information in supply chains can also be vulnerable to cyber attacks. So we have to consider that if I know the production or the estimation of production of my competition, I will be able to put the price of my products. So it is very, very important. So the Agriculture 4.0 is built on a set of digital technologies, IoT, big data, artificial intelligence, and a set of digital practices, cooperation, mobility, and open innovation. Digitalization of agriculture is based on the development and introduction of new tools and machining production, such as smart tractors, sensors, and so on. Precision agriculture refers to the collection of this data, and measurements are made in various ways, satellite, drones, tractor, on-site sensor. The problem of satellites and drones is the cost. Making analysis using a drone is very, very expensive. This is the reason a lot of people, including myself, are working on-site sensors. Automation also can increase in productivity and reducing and high connectivity is required, and which does not exist in all rural areas.
Victor, time.
Yes. Okay. Give me 3 minutes. Okay. Let me go a little fast on that. Give me 3 minutes. Okay. Okay. Okay, let me try to go to the final part. So there is a lot of application that you can see, but okay, I'm trying to get slide back. Okay, it's slow. Okay, but let me explain during the time. So I'm working, I was planning to provide you 3 examples. The first one is the one I'm doing on my PhD. I don't have the slide, I'm not seeing. I hope you are seeing that. It's based on the on-site monitoring of different. No, this is okay. The on-site, okay, it's improved the soil productivity. So to have a plant, the plant needs us to monitor a lot of parameters like pH, salinity of the soil, the humidity, temperature of the soil, and so on. This is something that doesn't exist today. This is what I'm showing in this slide. And so I'm trying to produce a system that will measure all these kind of things with the prototype block diagram, where I have all the necessary sensors to measure all that. And my idea is to have in this processor some processing and look for the relationship between the different parameters. So, for example, temperature of the soil and the humidity. And this is the current prototype I already have. And I'm doing some measurement right now on a lab that I have at home, because I'm at home now. This is the system. I'm also working with a university, Santo Tomas, where we are trying to do a lot of measurement on the field they have, where they have the vegetables. They also have the cherries, so we're going to put a node over there to measure those parameters, the nuts, and the greenhouse as well. And the node we are proposing will be measuring all these parameters. So you have the soil humidity, soil temperature, the temperature, humidity, soil salinity, and soil NPK, which are the nutrients of the. And this is the node we are proposing. I'm not sure I will put a solar panel. Maybe just a battery will be enough for the moment. And I think this is the last. This is something that is done at the University La Frontera in the south, which is taking in account the lambless and head in dairy cows and the detection of lambless, because this is something that is done manually today. So they are doing a project on that, and they are using also LoRa. So just to finish some conclusion, and you can start making your question over the chat you have. So some conclusion to finish. So food is a very important part of our life, and agriculture provide our food. Population is growing, so more food is needed. Arable land is decreasing, so we need to improve the soil yield. We need the precision agriculture, as IoT is the key. We are already implemented some prototype of the edge of one of the system. Machine learning will allow the IoT system to work independently, and artificial intelligence will provide algorithms to improve the yield. I need to work very close to agronomy, so we can understand all the processes. And just to give you an example of that, when I started my project, I had a meeting with agronomists, and they told me, okay, but what are you going to do? Are you going to work with tomatoes, lettuce, or what? I said, well, I don't know. Tomatoes and lettuce. They say, no, it's not good. You have to choose. Okay, say lettuce. Okay, which lettuce now? Because they are all different. Even if when we eat the tomatoes and the lettuce, we made salad. But they're all different. The condition to grow a tomato is completely different condition to grow a salad. Okay, so thank you very much. So I don't know if you have any questions. So I know that Carlos will be passing me the question. I don't know if Carlos already got some question. So thank you very much for that.
Okay. Okay, thank you very much, Victor. We have time for question. Yes, I have a question from the participants. Hello, Professor. Thank you for your lecture. Question. Which are the institutions that work in research in this area that are most relevant? Victor?
Yeah. I was reading. So what are the institutions that work in research in this area that are most relevant? Today, I will say that Europe, for me, is having more research than any other countries. They have this initiative that is called Food and Farm. We have a group at the CAS, IEEE CAS, that's called Food. We have a group of IoT for food that is mostly composed by European people. So Europe is going very far. India, China, and some other countries in that area of the world, and also Africa, are doing a lot of research because they need food, and they have more problems than the other countries, because they have a lot of people, India and China especially, and they have more climate problems, and they have more irrigation problems. And also, I would say that the one where we are lacking a lot of research in Latin America, because we want to present ourselves as a very important food producer, food exporter. I know that Peru, Chile is doing that. I know that Uruguay is very important on meat, as well as Argentina in soja and so on. But the research in Latin America for that is really short. I know a few professors that are working on that, and they are doing a very good job. But I would say today Europe I'm seeing in Europe a lot of research on that domain, and also in China and India. I hope that answered the question.
Okay. Another question is about IoT in agriculture. Which are the areas that most lacks of research?
I will say that one of the areas, in my opinion, that is missing that part is the area related to the soil productivity. Today, we know very well how to measure in situ the humidity and the temperature of the soil. If we go now, for example, to measure nutrients, the NPK, which is the nitrogen, the potassium, and the phosphorus, we don't have good sensor. We don't have not too expensive sensor, cheap sensor, because we can do that using a drone, but a drone is if quite expensive. So this is the reason that a lot of people are working on that. But this is just starting. So I would say the productivity of the soil is missing. This is for me the part. I'm trying to share my camera, but it doesn't work. Of course, the technology is not always too good. Okay, this is what I will say.
Mm-hmm. Okay. And another question is, are security issues also being addressed in terms of truth execution environments in this area?
Security, so sorry, could you repeat the question? So sorry for that. I was trying to share my camera, but I cannot. Yeah.
Okay. Are security issues also being addressed in terms of truth execution environments in this area?
Yes, they are. Security is becoming an important part of this area. I was giving some examples, but also there are examples about that we can hack, I don't know, the water or the fertilization of the land, so we can kill the production. Okay. So security is important as well. Yeah.
Okay. And o foco de, bueno, esto está escrito en portugués.
I can read Portuñol, don't worry. O foco de IoT
Okay.
puede también ser aplicado para transporte. Yes. Yeah. I agree. So I was talking more about IoT for food production, but of course it has to be applied also for transportation, warehouse, and so on. So this is because we have to cover the complete chain of the complete value chain of the food, and food starts at the farm and end at the consumer table. So we have to cover all that with IoT.
Okay. And finally, ¿cómo se mide el nitrógeno en una planta con IoT?
Okay, to measure the nitrogen, so there is a property of the soil that based on the percentage of, for example, nitrogen or potassium or phosphorus, the reflection of the light will be different. So if you put light on the soil, white light, I don't remember exactly right now, but if you get red, it means that you have this kind of product in or this kind of nutrient. If you get blue, it's another one. If you get etc. So it's based on the light. This is what the drones are doing today. What I'm working now is to put a small LED and have a LED an LED actuator that will send the light to the soil, and have LEDs sensor that will sense the red, the blue, red, blue, and green. Yeah, that answers the question.
Okay. Thank you very much, Victor, for showing a broad overview of this topic. And we will see in another opportunity. Thank you very much.
Thank you very much to everyone, and okay, see you later. Thank you. Bye bye. See you in another opportunity.
Okay,
Bye.
bye bye.